So we're here, Angela Giacchetti. I lead engagement and communications for the OMF, and we have with me Michael Schnerla, who's OMF's Director of Open Source Operations. And we are here today to talk about some terms that get used in our community: web maps, APIs, data standards, and we're going to unpack the difference between these. So with that being said, Michael, these terms are used often in our work as an organization that creates data standards. Um, and these data standards result in things like web maps and APIs. But can you explain all these terms to me, um, and do it in a way that is maybe accessible to someone like me who's not technical, so to speak?
Yeah, thanks. I'm Michael Schnerla, Director of Open Source Operations. I'm just going to go through and try to answer some of these questions for you in the context of our Curb Data Specification. So that's where this discussion has come up more recently, because cities are producing both web maps and APIs of their Curb policies in a digital way. And so let's talk through what those things mean. So first, I think the question we get the most is, what are APIs? It's a more technical term, but API stands for Application Programming Interface. But really what they are is just a digital way to send and receive information between different systems or organizations. So like between, a city has a computer system running and they want to send some information to a vehicle operating on the street, or that vehicle's company wants to send information to a city. APIs is how you do that. You send little bits of information. The Curb Data Spec APIs let governments exchange this information about the rules and policies in a consistent way with the companies, vendors, and different parking users. And then with CDS, we have three different groups of APIs. You can just see them here at the bottom: curbs, events, and metrics. So
I have a
let's just
quick question
yeah.
just about that. Really,
Mhm.
why are there three different APIs as part of the Curb Data Specification?
Yeah, and so most systems that have APIs have multiple APIs that get things to do. It's rare you might just have one piece of information flowing. So CDS has a lot of different buckets of information that needs to be exchanged. In the case of CDS, there's three areas. The Curbs API is the city's information about the digital location and policies of each curb zone. The events are things that happen at those curb zones and the information related to those transactions or activity at the curb. And then the metrics is another set of a group of APIs that basically take those two things, the curbs and the events, and make them understandable at a more reporting and metric level. And so with CDS, we have three different types of APIs that have information. With other data specs like MDS, we have 6 different groups of APIs, and just depending on the service, you might have one or more APIs.
Gotcha. Thanks.
So what is an API? We have an analogy here in a restaurant setting. So in the middle there, you see a waiter at a restaurant. So imagine the restaurant in the scenario of CDS is the city. So the city is running a restaurant and it has waiters, and the waiters are the API. So the waiter moves from the kitchen, who's the city, who's making things for customers. The customers here that are at the tables are the people, the companies that want to access the curbs. And so the waiter goes back and forth, talks to the customers. The customers tell the waiter what food they want. That order gets sent to the kitchen. The kitchen then makes the food and sends it back to the waiter. The waiter brings that and delivers that food back to the customers. And so these little bits of information between the customers and the kitchen are being transmitted in a standard way by this waiter. The waiter is like the interface between the customers and the kitchen. And so the analogy here is you've got a bunch of city curb managers working in the kitchen. They use CDS through the city vendors to send information and receive information using CDS that connects to the curb users. So Curb managers send the policy and location information through CDS APIs to the company so they know what's available and what the rules are. And then as the companies use that, and whether they use sensors or some other way of detecting activity, that information goes back through CDS in a standard way back to the city curb managers. And then you can think of the OMF in this analogy as the organization that is creating that menu that the waiter and the customers in the kitchen is using. So it's a standard set of documentation of how the restaurant, what the restaurant presents to the customers and what the customers can choose from and what they can send back to the kitchen.
So does that mean that the OMF handles any data directly?
It's a good question. The OMF does not handle any data directory. I think in this analogy, the OMF would be like maybe it'd be like the head chef coming up with the menu and the printer that prints the menus and makes it available for everyone. But in that scenario, like, that head chef is not really getting all the details of everything. It's just making it available and making this interchange happen.
Defining how it happens, right?
How it
As
happens,
opposed
yes.
to, gotcha. Okay.
Like maybe like you could think of us as even the person that might train the waiter in this scenario, like tells the waiter how to act and how to use the menu and how to interact with the customers, and then how to be nice to the kitchen and tip out the kitchen at the end of the day. But yeah, the OMF doesn't really get into any of that information that's getting exchanged.
And so in that way, maybe a data standard, this is along the lines of this analogy, is kind of like the standard operating procedure, but it's not the waiter itself, but it's
Right.
the rules that the waiter follows.
It's the rules the waiter follows. Yeah, that's right. Like the blueprint for the rules, the blueprint for the data, or the rules the waiter follows. Yeah. And so let's talk about the other side of things. So we talked about APIs, which is how to send bits of information behind the scenes. This is an example we're showing here from Seattle. They have a web map, which is basically an interactive visual map of what was being sent across through the APIs. So it basically takes all the CDS API curb and parking rules and policy and displays it online in this interactive visual map. It's really useful for people to understand all the curbs, what's happening, or like what the rules are at the curb. But this is not a system that would be used by your IT department, your vendors, or curb companies to integrate. It's more of a visual for some sort of, we would call them end user that's using a web browser to just get a sense of all the rules and dig in if they want to, but it's not going to be an operational exchange of a back and forth between the city and the vendors. And so this is definitely a valuable tool for cities to publish, but it's not the only thing they should do. They should definitely also do the APIs. And here's a slide that just gets into the back end of the APIs. So this is actually from Seattle's Curbs API. So basically they have all the information of like the dates of that the curb zone policies went into effect and the name of the street it's on and the available length of space available at the parking and what is it, an angled parking, is it how many spaces are there, what side of the street is on, etc. And so that goes into the zone, and then the policy has on the right has information about the days of the week and what is the fee to park here and what hours of each day do these policies apply to and which vehicles does it apply to, etc. And so all of that can be digitally communicated in this API file and sent back and forth between the city and the curb users. And that is very different than the web map example.
So useful to have the API to create the web map, but the API has applications outside the web map. Is that correct?
Yes, and I would say they're different but complementary, and cities should probably create both. They should create the web map to make it instantly understandable for the general public and or your city council or things like that, even some of your internal teams. But the API is required to make the understanding of that more seamless for anyone who's using the curb and for collecting information about curb usage back to the city.
Right. So anyone can kind of plug into this.
Yes, anyone can plug into these APIs that the cities create, as long as they have the technical knowledge, which most vendors and operators at the curb do. So this is a final overview of the differences and similarities between web maps and APIs. So a web map is an application. It's something that you have to run and present, and it has a visual interface, but it's useful for communicating your curb parking rules to people sitting at a computer. You're going to be at a computer, maybe on a mobile phone, but you need a device to see it. It's good for visualizing all your curb policies. It's a great reference tool, and it's good for communicating the scope of your work and policies to anyone. On the other side, there's the CDS APIs, and those are data standards. So it's a blueprint for how to exchange information. It allows communication between your internal parking systems, any type of parking system, and vendor and delivery companies. By having a standard, it creates this ecosystem of vendors and competition that allow scalability and reduced costs for all the vendor services and easier vendor expansion into more cities. So it helps both the cities by reducing the costs of these services and the vendors by allowing ease of expansion to other markets. For the cities, it reduces vendor lock-in because it's easier to switch between vendors because the data flowing between the vendors will be the same. And you can realize your curb policy successes sooner than you would without a standard. Like this accelerates the rate of information exchange than if there was no standard and you were just trying to use dozens of vendor systems. And then with the OMF's recommendation for the blueprint for the CDS Curbs API, these are required to be publicly available so anyone can use these APIs as well.
Can you shed a little bit more light on how exactly this creates scalability? Like, can you give maybe an example?
Yeah, so an example could be in the curb space. Let's say there's a vendor that is deploying meters in the city, and they are deployed at locations that have information about the policy and the rules and the cost for that curb, and then they have to send information back to the city. So imagine if they're deployed in one city and the city says, all right, here's a email or a PDF of all of our rules and policies and where you're going to put the meters. And then every time there's a transaction, somebody's parking there, we need you to send this list of things. Here it is in a PDF, go figure it out. And imagine that a vendor has to do that for every city they want to work in. They have to get a different PDF, a different set of requirements, a different set of rules. Maybe some want those reports or that data in the email, some want it in a database. So the vendor has to do that differently in every single city. With the CDS APIs, they can do it once in one city because all of this is now a standard. And then if the next city and the next city asks for that information and wants to provide that the rules to that vendor, they can just do it in CDS, and the vendor has already done that. And so once they do it in one city, they can do it in any city, and the amount of work is minuscule compared to having to do it ad hoc every single time.
That makes sense. Thank you so much for this explanation. If folks want to learn more, there's recordings of webinars that kind of give more of an overview of kind of what CDS is. We also have working group meetings that are held once a month where we collaboratively solve problems around curb management, and continue to develop the specification to meet new use cases. So there's lots of ways to get involved to both learn more and then get involved in the development of the specification. Anything else I missed?
No, thanks, Angela. Great questions.
Awesome. Thank you so much.
Bye.